Okay, so we want to very quickly look at simple. Oh, I gotta move my head again. I guess I'll move it over so these people are pointing at me. Um, so we want to talk about the different kinds of things that we can look at. So if you want to do a simple comparison, you want to say that one thing is different from the other. Your new test or your new it's gone. The word is gone. Your new intervention, your new therapy for stuttering versus the old therapy for stuttering. You want to make a simple comparison. This is a t-tests. You're going to use a t-test. We don't need to go into what a t-test actually is. I just want you to have this information for the future, possibly for the test. I don't know but I'm not going to go way in depth onto what a t-test is. I just want you to know a simple comparison is some sort of t-test. Now we can talk about really interesting design aspects. So this, by the way, what we're talking about here in these design aspects, these are important for both research methods and clinical methods. You can introduce these into your clinical practice and you're going to get a really good set of data. Remember, you're not just collecting data for research. We're also collecting data when we're doing clinical work as well. The data that you're collecting for clinical work is, where does this person start? How bad are they stuttering? What are their disfluencies like? Do they make these substitutions and distortions, X number of times? How bad is it? So you're collecting data at all these times. Any speech sample that you're collecting, that's data. So any of these can be applied to either research or practice. And in this way, research and clinical practice are extraordinarily similar. So the pre-test, post-test design, which is also sometimes called an A-B design or an AXB design. The X in this case stands for experiment. You do A, experiment, then B. Well, what this means is you're not just going to test people after you've done some sort of intervention. Makes sense, right? So we can give people the new intervention that we've come up with for disfluencies, and we can give people the standard intervention for disfluencies, and then we test them and we say the people who went through this have fewer disfluencies at the end. Well, okay, cool, but we don't know where they started. Maybe that group had fewer disfluencies overall before the treatments went into effect. It's possible. And so you need to do a pre-test, post-test design. Figure out where everybody is, then do the test, then figure out where they ended up. And at this point, instead of really comparing each other, instead of comparing the groups, you are comparing the groups, but you're not comparing their ending numbers to the other people's ending numbers. What you're doing is you're comparing how good they got. So you're comparing their progression to the other group's progression. And that gives you a better idea of what's going on. There are also confounds. There's confounds that we have to look at as well. Remember, when we were talking about getting speech samples, we talked about, are you always getting your speech samples at the end of the day? Maybe the person is tired at the end of the day. Maybe you need to also have them come in once in the morning or once in the middle of the day and see if the speech errors are consistent or if it's somehow due to fatigue. So one of these confounds is fatigue effect, and that's exactly what I was just talking about. You can get tired. You get tired of doing tests. So if you test too much, if you let's say you study for the GRE, which is the book that this guy has here. You study all morning, and then you go in to take your GRE. You might be so tired of taking tests like this that you do worse on the actual GRE than you did in any of your pre-tests or practice tests, I should say, because you're just done with it for the day. At the same time, there's something called a practice effect, which means that The first time you do something, you're probably not going to be super good at it. The second time, you're going to be a lot better because you kind of know what's going on. And this is also important for the GRE. It's all of you are probably going to end up taking the GRE. You need it to get into our master's program here at ASU. Pretty sure you need it for most master's programs. The very best predictor of doing well on the GRE. Okay, let me back up. The very best predictor of improving on your GRE is taking it a second time. That's it. There are people who go in and they take it one time and they take it a second time and they don't do any studying in between, nothing, and they do better the second time. There are people who go in and take it and then they study a whole bunch and they do almost maybe a little bit better than the people that didn't study, but they do better the second time. And we can say that a lot of this is practice effect. It's just purely doing it a second time. This is especially true for the GRE because it's such a weird test. They're asking questions that you haven't thought about in a long time. You have to do it in a room alone on a computer. It's an adaptive test too, so the more questions you get right, the harder they get. And it's just strange. It's not like any testing that you usually do. I mean, to some extent, you taking it online might set you up a little bit better for the GRE than people who take classes in person. They're used to, on a test day, walking in, we banter a little bit, and then they get a Scantron and they fill it in, then they hand it in and they go away. And some people are really good at taking tests like that, but then when it comes to this computer-based GRE, they freak out and they don't do very good. But the second time, they know what to expect, so they do a lot better. That's a practice effect. You can also have order effects. Order effects are simply that the first question you ask might influence the next question. I'm trying to think of a really good example. I can't think of a great question example. I can think of a good question example. So there's a really interesting study that asks, people watch a video of a car crash. And one question says, how fast do you think the cars were going when they smashed into each other? And already we're going to talk about the wording of the question. It's kind of like a leading question because of the word smashed. People will say that they were going a lot faster when they see the word smashed. But so then you have another question after that, like how important is it for us to promote highway safety? Well, you're going to say probably a lot more than if you got the question that read, how fast were the cars going when they had the fender bender? And then you might say like 30 miles an hour. How important is it that we promote highway safety? Yeah, it's pretty important, but I didn't just watch people, almost die. Which, of course, you didn't either way. They actually crash into each other at about 40 miles an hour. The wording changes the perception, changes the memory of what you saw, and then the second question coming after that question changes your answer to it. Another good one that I usually do in class is we can do this. Okay. Here's what I want you to do. If your last name starts with A2L, I want you to mute your video right now. I'm going to wave at you when I want you to unmute it, but A through L, last name A through L, mute your video right now. Go ahead. Okay, the rest of you, I want you to think about this. Rate, just in your head or write down on a piece of paper, how much do you like chocolate chip cookies? 1 to 10. If you really love chocolate chip cookies, that's a 10. If you hate them, it's a 1. Go ahead and think of your number. And now what I want you to do is, how much do you like broccoli? 1 to 10. Okay. All right. Now that you're back with us, everyone, I want people who are M to Z, I want you to mute your video now. A through L, let's give them a second to mute their video. If you haven't muted it yet, please mute your video. Okay, A through L. I want you to think about broccoli. How much do you like broccoli? 1 to 10. If you love broccoli, it's a 10. If you hate it, it's a 1. Think your answer. Now I want you to think about chocolate chip cookies. 1 to 10, how much do you like them? All right. Okay. We'll give you a couple seconds to unmute your video. So, I asked everybody about chocolate chip cookies. I asked everybody about broccoli. A through L got broccoli first, and then M through Z got chocolate chip cookies first. This may have some sort of an effect on your answers. In past classes, it has. It's a slight effect. It's not actually as strong as I would expect. But what I would think is when I ask about broccoli first, you might think, yeah, broccoli's not too bad. I'll give it like a 7. And then when you're asked about chocolate chip cookies, you might be like, what? Oh, well, I didn't know we were going there. Chocolate chip cookies are great, but they're at least 2 times better than broccoli, so I need to go up to like a 9. But if I ask you about cookies first, then you might put it at like a 7, and then when I ask you about broccoli, you're like, well, broccoli's good, but it's not as good as cookies, so it's got to be down at like a 5. So then I would expect there to be a little bit of a difference between chocolate chip cookies based on when you got that question. And like I said, in past times there has been. That's an order effect. What I want you to do is give me your ratings as your word of the week. So go in, and I want you to put it in the order that you had it. So type in broccoli 7, cookie 9, or whatever, if that's the order you got it. So if you got broccoli first, tell me broccoli first. If you got cookie first, tell me cookie first. What I'll do is I will do some statistics on this and let you know what happened. So anyway, your word of the week is the food item and your rating of it, and then the other food, your next food item and your rating of it. And that's an order effect. Oh, yeah. Okay, I see what I'm going for here. So you can add a control group that doesn't get whatever intervention to help identify the first two. So let's say that you have some sort of fluency, Goldman-Fristow test, or something like it. That's not necessarily going to something that we would always use for disfluencies, but let's say we did, just to have something standard that we can count how many disfluencies our participant makes. So we show them this test. We count how many disfluencies there are. Then we go through either our new treatment or the standard treatment, and then at the end, we give them the test again. Well, we'd assume that if we did a whole bunch in one day, they might be fatigued, or just purely because we'd given them the pre-test, they might do better on the post-test. What we can do is we can have a control group that didn't get any intervention in between and see what they did. Did they get worse? Did they get tired? Because maybe, if you're testing people on the same day, if it's a really fast intervention that happens in one day, you'd give the group that got nothing the same test in one day. You might see a fatigue effect. Or you might see a practice effect if it was over a couple months. So adding that control group with no intervention can help you figure out what's going on. You can see what their practice effect or fatigue effect is, and then subtract that from your actual groups. There's also something called an AA AXBB design, if you extrapolate from the AXB design, you might understand what that is. But essentially, it's 2 pre-tests and 2 post-tests. So what you're doing there is you're really figuring out what the practice effect is. So how much better do they do from A1 to A2? How much better do they do from B1 to B2? And then you kind of like infer like, okay, they're getting this much better, so we can subtract that from A2 to B1. And anything left over from A2 to B1 is actual improvement. That's called an AAXBB design. Counterbalancing can address the third. And counterbalancing is exactly what I did to you guys. If you have some sort of survey where you're going to ask about chocolate chip cookies and then broccoli, counterbalancing is on half of the questionnaires. You switch the order of the question. And that way you're not necessarily removing the order effect, but you're going to average across those answers, and you can assume that the right answer is somewhere within that average. We have just a few more slides. I want to talk about between subjects and within subjects designs. A between subjects design is really simple. Just means that it's between people in the 2 groups, right? So let's say that you have someone who gets your intervention and someone who gets the other intervention. You're testing between these 2 people. The differences between them. What happened? With the within subjects design, the difference is inside the person. So let's think of something that a person can do. So, okay. Yeah, okay. Running could work. So let's say that we want to test out how much better you can get at running by drinking some sort of energy drink. We've got 2 energy drinks. We want to see if one makes you better at running, right? So you have like, I don't know, one called Explode and one called Slow Down. I don't know. It's a stupid premise. Anyway, so you could have 2 different groups. You could have it where you have one group drink Explode and one group drink Slow Down. And you can have them both run, and you can, test how fast Group A was versus Group B. And this would tell you something. But of course, there's all sorts of individual differences within people in your groups. It's possible that Group A would have ran faster no matter what. So you're not necessarily sure. In that case, you should do a within groups design, within subjects design, where you give a person Explode and then have them run. And then a couple days later, when all of the effects of that have worn off, you give them Slow Down and then have them run. And compare their times. So you can still have 2 groups. What you'd want is to have one group that gets Explode first and Slow Down second. You'd have your other group get Slow Down first and Explode second. But really what you're doing is you're comparing each individual person's time from one to the other. So there's 2 groups, but really you're just having the 2 groups there so that there's no order effects. Your overall difference is actually coming within the person. It's coming from me. How fast did I go with one? How fast did I go with the other? With the between subjects, again, this is where you give one group one drink and one group the other drink. The difference exists between a person who got that drink and the person who got this drink. The difference is here, between, in the space between them. So usually within subjects design is better because you're accounting for your own slowness. Like, I'm not a super fast runner. There's tons of people who are faster than me. And that doesn't mean that it didn't cause a difference. So we're kind of removing my base running speed from the experiment entirely. and we're taking somebody like Usain Bolt, and they are very fast, and they still might have a difference between these two drinks, but you want to remove their basic running speed and just look at the difference. So it's more well controlled. It's preferred that you would use within subjects. But if it's preferred, why do we even have a between subjects? Because sometimes you can't. Think about our intervention, our stuttering intervention. You can't really give someone both stuttering interventions and see which one is better, because if they both work to some extent, you give someone your stuttering intervention and then you give them the next one. What if this cured them? Then you're not going to see anything. You give them the other one and they get a lot better, but then they have yours and they get a little bit better. They're cured, but it's just a little bit because they were already good from the other one. Sometimes it doesn't work. Sometimes you can't have a within subjects design, and that's why we have between subjects. What you really need to take home from this is what the difference is of between and within. Between is two people, the difference between two people. Within is one person, they're doing both things. The difference is within them. And why one is better than the other. And that's because within removes each person's individual differences that they bring to the table. Okay, so designing good measures, if you're going to have some sort of survey, you want to get rid of loaded questions. Here's a loaded question. Do you agree that reputable businessmen like Jabba the Hutt, who is providing jobs for the people of Tatooine, are being persecuted by rebel terrorists? Yes or no? Well, of course, there's tons of stuff in here that makes you feel like you should say yes, right? The rebels are terrorists. Jabba the Hutt's a reputable businessman, so you're going to want to say yes. This seems like a cartoon example, and I mean, yeah, there are Star Wars cartoons. That's not what I mean. I mean, this seems like I've overblown this to a ridiculous extent. Except I recently saw a very similarly worded question for leading up to our actual 2020 elections. It was like just as stupidly worded. Like you could, if you had an IQ of 50 plus, you could see through it to what they were trying to do. But it's a loaded question. They don't always have to be this obvious. And I was actually surprised that it was so obvious. Usually they try to be a little bit more sly in their wordings, but they weren't. It was just like, hey, it's right here. Here's how poorly this campaign is being run. Order effects will come up here as well. They can come up in your surveys. If you really want to know whatever you're looking at, you don't want to have order effects. Of course, sometimes, again, with these political questionnaires, there are order effects to the questions that they want to have in there. You can also check for reliability with reverse questions. I'm sure you've seen this on a lot of internet questionnaires that you've taken. If you've ever done those personality questions. So it'll be like, how often do you steal? Always, sometimes, or never. And then how often do you not steal? Always, sometimes, or never, right? So then you're just making sure that they're answering the same when the question is reversed. So if you always steal, then you never not steal, right? And then you also just need to be aware that all survey research is like highly suspect. Survey research isn't good. People like to answer surveys, these like socially desirable responses. Some people will answer what they think they should, even though they know that it might be anonymous. They still answer the way that they think they should. For example, this is a really well-known example in the psychology literature, but they made a point of saying to this group of college students, like, hey, it's totally anonymous. You're going to fill this out, We're going to take it from you face down. We're going to shuffle these up before we look at them. There's no way that we're going to know who said what. Okay, cool. So then what they looked at was, one of the questions was like, how many sexual partners do you have? And men, they look specifically at straight men, and the straight men are like, like 7. And then they look specifically at straight women, and they're like 1. And there's no way that if these answers are right, that you can have straight men with 7 sexual partners, but straight women with only 1. The numbers don't match up. So they're either making socially desirable responses about the number of sexual partners or about their sexuality. One of the two. But whatever it is, it's still a socially desirable response. So people lie on surveys all the time, even though you can hit them over the head with the fact that they're anonymous. People will also fake how good or bad they are. If you ever took these DARE surveys when you were in high school, which I'm sure most of us, if you're my age, it was like every week we had a DARE survey. And they're like, which of these drugs have you done? And of course, like I've never done any. Like in high school especially. Like my parents knew where I was all the time, and they made sure that I did my homework and stuff, and of course I'd never done any drugs. But then you get the questionnaire and it's like, have you ever smoked weed? And you're like, yeah. Even though it's anonymous, you're just like, yeah, totally, yeah, absolutely, all the time. But not really. This is faking bad. You can also have people fake good depending on what it is. Again, this is probably just another coin of socially desirable responses. But we make these crazy responses all the time. Survey research is just not super great. Especially when it's like social, like attitude stuff. If you ask somebody like I asked you guys, like, how much do you like broccoli? You might be able to trust that a little bit more. There's no maybe some of you are liking broccoli a little bit more than you actually do. Maybe. But maybe not everybody. Okay. Generalizability. Let's not even talk about this. Just there's problems with generalizability. You have to make sure that your sampling is random. This doesn't really come up with the kind of things that you guys will be working with. So let's skip this slide. And I just want to end on kind of a summary here. How do we do good research? You want to have a falsifiable question. That's the very first thing. Your research question has to be falsifiable. It has to be possible to get a no. There can't be some sort of crazy out like Bigfoot is interdimensional, or you just don't remember the trauma, but it's definitely there because psychotherapy has to be right. Those are not falsifiable. It has to be feasible. I mean, it should be feasible, and by feasible, I mean can actually be done. My idea of everybody canvassing the forest to look for a Bigfoot is not feasible, because how can you get that many people walking through a forest? There's not the manpower or the money or the time to do something like this. So it needs to be feasible to actually get done. You need to identify your variables. What are you going to change, and what are you going to measure? What is your independent and dependent variable? What are you holding constant? So what is your control variable? And then what are other potential confounding variables that you can't even control for? One of these people like to look at IQ differences between states, between areas and things like this, right? Between counties and cities. And you can say like, oh, well, Mississippi always scores worse. They're the lowest in IQ. Does that mean that there's something different about Mississippi? Like the water is bad and it makes everybody stupid? No, I mean, one potential confounding variable here is that Mississippi also is one of the poorest states. So there's a different culture, which can change how well you perform on IQ tests. You can actually have a really smart person, but has such a different culture, like a low socioeconomic status can create a completely different culture where they don't even perform well on the IQ test of, say, upper middle class people that come up with it. And so that's one of these potential confounding variables that exists. You can't really control for it, but it might be there. So there's control variables that we can control for. There's potential confounding variables that we can't. But it's kind of a responsibility you have as a researcher to identify what else might be going on. Yeah, my research shows this is true, but it could be that it's this. And then if somebody actually does it, you also get a little bit of credit for thinking that it might be that too. You also need to identify what kind of data you're expecting to get. It's always best if you can work backwards from what you expect your results to be to figure out what kind of design you need. If I know that I want to do a t-test between two different types of stutter reduction therapy, then I know that I need to set up two groups. I know that it can't be a within subjects design. It has to be a between subjects design. And I know how I can set up my study. What you don't want to do is not think your research through very well and end up with a between subjects design when you should have done a within subjects design that would have given you better data. You also don't want to collect data from two different groups when really all you're doing is running a correlation, because then what have you done? And then the last thing, the very last and most important, equally important as finding a falsifiable question, is always be truthful with your results and anything in research. The goal of science is finding truths. In fact, it's really the only way of building facts. You can say that you can logic stuff out, like you can use deduction or induction, inductive reasoning, deductive reasoning, all these things to come up with facts and find things out, but that's not really true. I mean, you can use that to come up with a hypothesis, but then it needs to be tested. Things always need to be tested. That's how we find actual truths. There's no other way besides science. And distorting any facts hurts what science is. So any sort of lying about research findings, as small as they might be, impacts the integrity of the entire field. So we've had people, the anti-vaxxer movement was started by one person lying about their results. I don't know if you know this, but this is 100% true. There was a paper that came out in the early 2000s, I think, it might have been the late 90s, that said, hey, vaccines are linked to increased rates of autism. The guy got really famous. He published more studies, went on a bunch of talk shows and talked about this. He got money for writing books and stuff like this. And then when he realized that these findings were making a whole generation of people go without vaccinations and catch German measles and things that we should not be catching because we have vaccines, finally came out and said that the whole thing was a lie. But he just basically had published that paper to become famous within the scientific community. So it potentially killed people. I mean, if anyone had died from not getting vaccinated, this guy's actions led to that death. So in addition to hurting science, it's also hurt people too. And I don't think anything that we research in the realm of speech will cause death. But if you lie about your findings just to get, published or something like that, you could lead to people using a type of therapy that isn't better than the typical one, or is actually worse than what they had been using. So you can lead to people not having as good of prognoses as they should otherwise. And then again, it hurts the integrity of science in general, because when people find out that a scientist has been lying, it makes them wonder, well, what can I actually take as fact? And so it's always good to uphold the truth of science, and always be truthful to the study that you're doing. Okay, that is the end of this lecture. I might have a very short one on the parts of clinical methods that don't align with also the research methods, but certainly this last slide goes along with it as well. All right.